Right, last note section, guys and girls, with another fun-filled, action-packed, non-flipped Algebra 2 classroom video. Notes number 4 about rational exponents. The very first thing we're going to do is write down 3 very important properties that we're going to be using throughout today's notes. So here we go. If we have 2 terms and the base is the same, oh, is it now? Whoa, wait a second. All right, if we multiply 2 terms with the same base, then what happens with the exponents on those terms? They are added together like this. The base doesn't change. It's the same base, but now the exponents are added together, right? That's one of the properties you guys have been using. Now another property is if I have a term being raised to a power and I raise all of that to another power, that is going to be the same as having that term raised to those 2 numbers multiplied together. Right? We multiply this exponent in with the other exponent. Yep. And then the last property is if we have multiple terms inside of parentheses like this, and all of that is being raised to a power, that is the same as every term inside the parentheses being raised to that power. This power distributes to every term inside the parentheses. Like that. Okay, so pay attention to these 3 properties because we're going to be using them throughout today's notes. It's very important that you know them. Okay. So this is some stuff that we're about to cover at the bottom over here. This is about rational exponents. We've actually already talked about rational exponents before, but today we're going to go more in depth with them. So what are rational exponents? They are exponents with fraction exponents. So when you see a fraction as the exponent, that is a rational exponent, okay? Now the top number of the fraction represents the power. Let me put some colors up in here, you know what I'm saying? Represents the power, and the bottom number of that fraction, of that rational exponent, represents the index. All right? So let's take a look at these 3 examples right here. Evaluate. So you can see all of the exponents here are rational exponents. Why? They're fractions. Okay? So if you take a look at the first one, 16 raised to the 1 over 4. How am I going to evaluate that? Now remember, the top number represents the power, right? So this is the same as 16 raised to the what power? 1, which really doesn't change anything, right? And then the bottom number, the 4, is the index. So what am I looking for here, actually? I'm looking for the 4th root of 16 raised to the 1st, or it's just 16, which is 2. That's right. Because 2 times 2 times 2 times 2 is 16. So that's the idea. So on B then, what would I be looking for on B? Right, the cube root of 27. Technically raised to the 1st power, but you know, that's just 27. Which is, so what is the cube root of 27? 3, that's right, very good. And lastly, what about C? Cube root of negative 64. Raised to the 1st, which is technically just negative 64, which is negative 4. That is right. Now notice, you took all of these terms, right, that were written with these rational exponents, and you changed them into radical form, right? You changed it into a radical, so that way you could see what the answer was, right? So keep that in mind, what you just did. Okay. Now here's a question. What if you have numbers on the top and the bottom? Then what are you going to do? Now watch this. On A, can you rearrange A just like you did the other examples we did above? What would it be? 25 to the 3rd. And then what? Square root of 25 to the 3rd. That's right. Don't really need to write the 2, but I'll just do it just so you see it. Okay, now, what's the problem with this? Do you know what 25 to the third is in your head? Off the top of your head? No, you don't, right? It's a pretty big number, you know? I'd probably get a calculator to do this one, but watch this. This is actually the same if you split it into 2 steps as the square root of 25, then cube that. That's a lot easier, right? You can actually find the answer to this one. What is the square root of 25? 5. And so now you just have 5 cubed, which is 125, and that's what the answer is. So to make it easier on yourself, when you have numbers in the top and the bottom, it's better to take the root first and then apply the power. All right, B. If I wanted to apply that same concept, what would I do on B? Cube root 27 and then? Right, cube root 27 and then square that. Let me put some colors in here. Whoops. Whoop. So what is the cube root of 27? 3. So we've got 3 squared, which is? What? 9. There it is. 9. And how would you go about solving C? The cube root of negative 125. And then what do I do with that? Square, right. So what is the cube root of negative 125? Negative 5. And negative 5 squared is? 25. Very good. All right. Okay, so now right here, some examples of simplifying the expression. All we're doing here is applying those properties of exponents, the first 3 properties that we wrote. Okay, so if you look at A, is 10 to the 1/2 times 10 to the 1/2. How would I solve this right here? Not quite. So if you look at the properties up here, when I have the same base, look at this. What do I do with the exponents? I add them. So my answer right here, because the base is the same, it's 10, right? I can just add the exponents. It's going to be 10 to the what? To the what? What is 1/2 plus 1/2? 1. 10 to the first, which means the answer here is 10. There you go. All right, B. Now B is a little different because notice the bases aren't the same, right? But I can change one of those numbers to match the base of the other one. The 16, right. How can I change the 16? 4 squared. 4 squared is 16, right? And now it has the same base as the other term. It has a 4 as the base. But this 4 squared is being raised to the 1/3, so I have to account for that. And then times 4 to the 1/3. So this is where you have to apply your exponent properties. Right here I see the 1/3 on the outside of the 4 squared. So what happens with these 2 exponents? They multiply, right? Multiply those 2, which gives you what? 2 over 3, right? 4 raised to the 2/3 times 4 to the 1/3 now. And now what can I do? What's my next property? Yeah, it would just be 4 to the first because 2/3 plus 1/3 is 1. And then 4 to the first is just 4. And there you go. All right, last one, C over here. Negative 3 raised to the 1/3 times negative 3 raised to the 1/3 times negative 3 raised to the 1/3. What would that equal? Negative 3, how did you get that? What do you mean? Explain more in depth. That is not really, clear. Yeah, the exponents. So because the bases are the same, I can add all the exponents, and then 1/3 plus 1/3 plus 1/3 is 1, right? So this is -3 to the 1, which is just -3. All right, so there it is. Now, moving on to the next section, this is converting between exponential and radical forms. So we kind of did something like this before, where we switched from, logarithmic to exponential, but this is possibly even easier than that one. So, switching between exponential and radical, right here, these are exponential, you see? There's exponents there. We want to change them to radicals, and you already did this in the very first thing we did. Look at these. There's exponents, right? We changed them to radicals. So can you do the same thing now with variables? How can I rewrite this x to the 1/5 as a radical? X to the 1, right? The 5th root, that's right. So the 5th root of x to the 1st, that's it. That's all you had to do. What about b? That's right, 8 root of y to the -9. Now, one thing about this is that you don't write negative exponents like this. So how can I change this y to the -9th to be a positive exponent? You change it to be the 8th root of 1 over y to the 9th. Negative exponents means it goes on the bottom of a fraction. What was that? Yeah. And lastly, what about c? 7th roots of y squared, right? That's right. That's it. That's switching from exponential to radical. So now turn the page over, and we're going to go the other direction, from radical to exponential. All right, so there's many different ways you can do these ones. However, I'll show you the process you can do on each of these problems. So you can take each term separately. So on A, we're going to change that into an exponential form, right? So take each term separately. So I'm looking at the 7 first, right? On the 7, what is the power of the 7 that's inside here? 1, right? The power is 1. You don't see anything there, so it's just 1. What's the index? 2, because it's a square root. So we have 7 raised to the 1/2. Now we do the x, right? X, what's the power on x? 3, and what's the index? 2. And that's the answer. You switched from radical to exponent. Okay, let's look at B now. B, they're doing everything at once, right? So here on B, we've got 7x. 7x, what's the power on 7x here? 3. And what is the index? 2. So we've got 7x raised to the 3/2. But now we have to apply our exponent properties. So what happens with that 3/2? It goes to both of the terms, right? So what's my final answer? That's right, 7 raised to the 3/2 times x raised to the 3/2. There you go. And lastly, we're looking at C. How would you start off C? You could do it one at a time, but you see how they put it in parentheses, right? You can take care of it all at once.
Take out 5, put 6 for all of them. So 5, 6, and 5x and 1.
Okay, so yeah, a way that you could do this a lot quicker, right, is you see how it's in parentheses, right? Do the same thing, 5xy, right? It's being raised to what power? 6. What's the index? 3. Now, how can I reduce the 6/3? 6/3 reduces to what? 2. So we've got 5xy to the 2. And now what do I do with the 2? Distribute it as a power to all the terms inside. So what's my final answer? 5 squared, which is 25, and then there you go. Just like that. All right. So that is converting between exponential and radical form. All right. Next up, combining radical expressions. Take a look at this problem right here. What is the simplest form of this term, this expression right here? First things first, remember we learned about dividing, right? Can we divide what's under the radicals here? Yes or no? No, why not? What's wrong with this? That's exactly right, because the indexes are different. Remember, you can't divide what's under the radical if the indexes are different. But we can use the new rules we just learned to actually simplify this whole expression, though. And if you follow the process, you'll understand this. But first thing you want to do is take all your terms and switch them into exponential form. Okay? So we're going to take this first term. How would you change this into exponential form? X to the 3/4, very good. Times, now we're going to take the bottom and change that to exponential form. What would that be? X to the what? Close, but there's one problem with that. Notice, this is on the bottom, right? Which means the exponent would have to be negative, right? So negative 2/8. Okay, so there we go. Now you see we have the same base, right? Both are a base of x. We're multiplying. So what can we do here? We are multiplying, but what? How can I go from here? What should I do? Using the properties. When I have the same base, what happens with the exponents when I have the same base and I'm multiplying? They add, right? So I want to add the exponents, right? But what's wrong with that right now? The denominators aren't the same. But is there a simple way I can make them the same? How? Without even doing that. So one of them set up already to where I could have the same denominator. Yeah, look at x to the negative 2/8. That reduces. What is negative 2/8 reduced to? Negative 1/4. And now they have the same denominator. And so what's my final answer now? X raised to the 2/4, which reduces to? Right, x to the 1/2. There you go. All right, let's take a look at a few more examples of this. See if you guys understand the process here. So, on A, what is the first thing that I wanted to do here when I'm encountering this kind of problem? I can't multiply because the indexes are different, but what can I do? If I can't multiply, then I can't divide either. What did we do? What did we do first here? Converted them to exponential form, right? So we're going to take each of the terms and convert them to exponential. So what is this first term in exponential form? Very good. What about the second term? That's right. Okay, and now what can I do with these? Add the exponents, right. However, one's 1/4, one's 1/2. I can't add like that. What do I need to do? Well, why can't I add them right away? The denominator is different. How can I make the denominators the same here?
You make x to 1/4, x 1/2, and x 1/2.
No, you can't just change it like that. It has to still equal the original thing. You can't change what it equals. Yeah, multiply 1/2 by what? 2 on top and bottom. You want the denominators to be the same, right? The denominator here is 4. You see? I want this one to be 4. How can I bring this 2 to a 4? Times it by 2, right? But I can't just multiply the bottom by 2. That's cheating. If I multiply the bottom by 2, I need to multiply the top also by 2. So then this ends up being, and 2/4 is the same as 1/2, right? So there you go. But that lets us actually add the numbers now. So what would my answer here be then? Right, x to the 3/4. So you do have to know how to add and subtract fractions, which is a struggle. All right, B. This one is a little more complicated, but same process. What do I do first? Convert to exponential. So what would the top term be in exponential form? X to the 4/2. Right, y to the 1/2, right? Now, what about the bottom, though? This is the tricky part. Close. To the negative 2/4, right? Remember, it's on the bottom. And then? Right, y to the negative 8/4. Okay, so now I'm going to multiply these terms together, but before that I should reduce the fractions. All right, all the exponents are fractions. So what does 4/2 reduce to? X, oh, wrong color. X squared, that's right. Y to the 1/2 doesn't reduce. And on the other one, what about negative 2/4? Right, and then what about the y? Y to the negative 2, yeah. Okay, so now we want to multiply the like variables, and when we multiply the variables that are the same, we add the exponents, right? So look at the x's. What are the exponents on my x's? 2, which is 2/1, and negative 1/2. So I'm trying to combine these two, but I can't combine them right away. Why? Right, the denominators are different, so how can I make them the same? By 2/2, right? Multiply by 2/2. And so what would that come out to be? 4/2, right? So I can change the 2/1 to 4/2. Now the denominators are the same, so we can actually subtract. So what would that end up to be? 3/2. So x has an exponent of? That's right. Now let's do the y's. What are the exponents on my y's? 1/2 and negative 2, which is negative 2/1. Once again, I can't subtract them because the denominators are different. So how can I make them the same? What? Right, multiply the negative 2/1 by 2/2. So what would that end up being? Negative 4/2, that's right. So now we have 1/2 minus 4/2, which is negative 3/2, that's right. So that means the exponent on my y is negative 3/2. Okay, but I can't write my answer like that because there's a negative exponent, so my final answer should look like this. X to the 3/2, and where does the y go? On the bottom, right. Y to the 3/2 on the bottom. Because it's a negative exponent. All right, last one is C. Okay, so remember, what is the first step here? What's the first step? Anybody? Turn to exponential form. So what is this top term in exponential form? Right, y to the 9/3, good. And what is my bottom term in exponential form? Close? Negative. Yes. Negative 3/9. Okay, so let's reduce those fractions. What would they end up being? Y to the 3rd times to the negative 1/3, right. Okay, so now that the bases are the same, what can I do here? Add what? Right, we're going to add the exponents. So we've got 3 over 1 minus 1 over 3. But that doesn't work because the denominators are different. How can I make them the same? Right, multiply by 3 over 3. So what would that end up being? 9 over 3, right. Whoa. And so what does this end up being? So what's my final answer? Y to the 8 over 3, that's right. That was 3 over 1, right? And we want to make it at the same denominator. So we have to multiply top and bottom by 3. So there it is, y to the 8 over 3. All right, now we did have a very long, complicated example, but it's pretty redundant, so let's just skip to the very bottom now. Simplifying expressions. All you're doing when you simplify the expression is use your properties of exponents, okay, and radicals to simplify your expression. So right here you see on A, we've got x raised to the negative 4 over 7 raised to the 7th. So what property can I apply right here about exponents? Multiply the exponents, right. So what would that come out to be? I don't think that's the right number, but regardless, check this out. Negative 4 over 7, I don't know if you remember learning this rule. Negative 4 over 7 times 7 over 1. I can cancel the 7s because there's 1 on top, 1 on bottom, which leaves me with negative 4. Yeah, it's multiplying straight across, so that means x to the negative 4, right. But I don't want to write with a negative exponent, so how should I write my answer? It's going to be x to the 4th on the bottom. Nothing's left on top, so we just put a 1. All right, when you have the negative exponent, it should go on the bottom of the fraction. All right, now let's try B. So let's apply the properties of exponents here. What should I do first? Right, distribute the 1 over 5 to where? To the 15 and also to the negative 32, right. So that gives me negative 32 raised to the 1 over 5 times y to the 15 over 5, which is 3. Yeah, because 15 over 1 times 1 over 5 is 15 over 5, which is 3. Okay, that's not it though, because we've got negative 32 raised to the 1/5, which is the solid number. How do I find that number? Turn it into a radical, that's right. How?
Negative 32 to the 1.
To the first power, right? And then find the 5th root, that's right. If I do this, that will give me the number value for negative 32 raised to the 1/5. And what is that? Negative 2, yes. Okay, negative 2. So what's my final answer here? That's correct. There we go. All right, there it is. So that ends our final notes section for this unit. So until the next unit, guys, I will see you then. Peace!